decide to use, of course, you're going to constrain it based on how much financial resources you have, how much space you have, and how much labor you're willing to put into it to put it together. Now, if you think your project is too big, then it's time to enlist the members of the club to come out and help you do it. And so when we did this antenna here, Wes and I, WD7P and I, we dug all the radials in. It has 60 radials per vertical that are 2/3 of a wavelength long. There's 21,000 feet of wire that's buried in the ground as the ground field for this antenna. Wes and I did that, but when we put the verticals up, I had the whole club over. We called it an event, antenna raising party, and we put the antennas together, raised them up, and guided them in place, and then had a barbecue afterwards. Put these kinds of events together in your club. Do it. Yes. Go ahead.
How did you feed them? No shunt fed or they're insulated?
They're insulated at the bottom, so they're bottom fed. Now, a phased array is interesting in the respect that we feed each of the elements with a different phase from the main element for it. I don't know if that means a lot of it to you, but we shift the peaks and valleys of the RF wave by 90 degrees for the ones that are on the corner, and then for the one that's in the back, we shift it by a full 180 degrees for it. And so the feeding of this antenna is based on a characteristic of a quarter wavelength line at the frequency that we run it at, which means that the impedance of the antenna does not enter into the equation. It's the output, the characteristic impedance of the feed line divided by the voltage that we put out there on the end. That way we get equivalent current at the end on all of the feed lines. So it makes feeding it a lot easier. So to answer your question precisely, there is no matching section at the base of the antenna to match it up to the antenna. That's one of the advantages of doing that. Another question? Yeah. No? Okay. All right. Any questions? Yeah, Amit, somebody said, don't get too technical in this, and I've been known to do that, is to turn the nerd knob up a bit too high. But that, if any of you are interested in and got the space to put together an antenna like this, these kinds of antennas can be built for any band that you want to do, and they are just as effective as a beam that's sitting 60 feet in the air on 20 meters. They build a 20-meter size, and for this kind of antenna, 20 meters will easily fit in anybody's backyard.
You basically, are you steering that one or as
Yes, you steer that one electronically, and so you have 4 directions, or you can build so it'll steer in 8 directions if you still want to go to the extra work on the phasing switch arrangement. But all you're doing is just changing where the antennas are being fed at, and you can change direction at will. It turns faster than any rotator, I can tell you that. But it's a great antenna. It works really, really well. Okay, rigs, you can be expensive or you can be cheap. Like, this is like a couple of examples. This is a 450 on one side and a FTDX 5000 MP on the other side. This one over here you can buy for $900. The one on the other side will cost you $6,000 for it. And they get more expensive than that. Now, do you need all of that horsepower in it? When you get to the 275 country mark, and there's a whole bunch of other hams that are in the same boat, and you're all competing for the same very rare DX out there on the far side of the world, then it can give you the edge to make that contact where you may not make it before. Is it absolutely required? No. Therein is more related to your skill as an operator than anything else for it. Yes, it does have an advantage, but you can make up for it by just raw skill for it. The one that I have, there was a question answered there, mine is the 5000 MP DX 5000 MP. It is a fabulous radio. One of the things that some things that you will look for very quickly when you start chasing DX is the ability for the radio to listen to two separate frequencies at the same time. It is true that you can get by without it. In fact, I actually have a sound bite that you can listen to a guy that's actually switching between VFOs to hear both sides of a conversation. And so you can hear what it's like, but it's easier, much easier, if you can hear both sides of a pile up at the same time. Because most DX operators will operate split. We'll talk about that in a minute too. So you can get expensive, you can get cheap, but whatever it is, just get started for it. And obviously a lot of you already have an HF transceiver. Well, guess what? That's where you start. That's where you're going to start doing this sort of stuff. You're going to start right there. You're not going to go out and buy a brand new rig or stuff like that. Because, to be absolutely honest with you, these new rigs with all their fancy bells and whistles and stuff like that, you'll spend more time learning how to use the radio than you will operate. And so, well, and a good portion of it can be achieved just through developing your own personal operator skills than actually going out and buying a $10,000 radio. Here's the new one, the 990 out by Kenwood. Ooh, it's pretty. It's pretty price tag too. Okay, and since they're gonna talk about propagation and other stuff like that, we'll just sort of browse through it real quick. But generally speaking, this is the kinds of things that you're gonna be looking for. For those of you that are beginners at it, this is all you need to know. Now, it is true that later on you're gonna want to get a lot more exotic about it. And you want to know exactly what band is open where, when, so forth and so forth. Well, this is the kinds of software that you can just download and build your propagation maps from it. This is based on a dipole antenna on the 12th of February at 6 p.m. on 20 meters with 100 watts. Every area that is lighted, you'll be able to communicate with on that. This goes to show you that most of the time when you go strolling across the band on 20 meters and you think it's dead, no, not likely. It's just that there's nobody talking at that time. All of those red lines across there, that's the CQ zones that we were talking about earlier. So you can see that a good portion of the world is open one time. This is a DX Atlas, the VK9 right there. That's the VK9. That's Copus Keelan Island right there. This is DX Atlas, is the display software. The modeling software that models the propagation data is called HamCap. It's free. You can just look for HamCap to be able to find it. And this particular, the mapping piece of it that gives you a nice big map to look at, is it costs like $75. It's, pardon me, 25 now? Oh, good. Dropped the price on it. But it was 75. And this uses the standard VOA cap software to actually do the computations. It has a bunch of antennas that are already in it that you can use for a general antenna model for both the transmitter and receiver sides, and then you can adjust the parameters for it, propagation parameters, sunspots, K factors, blah, blah. We won't talk about that, but we'll.
I'm an antenna guy. One thing that's the EasyNet simulator I showed you last week, that will generate files that'll run with this stuff.
That is correct. In fact, for my own station, just so that I could be accurate, I modeled all of my antennas extensively and then used those models to actually predict my propagation anywhere in the world where I wanted to go. Yes?
And it works.
Do you use separate receive and transmit antennas?
There is an advantage to do that on the 80 meter and 160 meter band. I have never done much of it. As I progressed in my DXCC totals, my next major challenge, of course, is 160 meters, and I will be putting up some receive-only antennas specifically for that. Something that is low noise so that I can knock some of the noise down. Yeah, it becomes important. For most bands, it's not that big of a deal. For like 40 meters and up, it doesn't have a really significant advantage, although there are occasions on 40 meters when you could use a low noise antenna. For the other bands, it's like, okay, you'll make the contact without it. Okay, from a logging, most of the time, for all of the awards that you're going to want to get, you don't have to log anymore. But if you want any of the awards that we've talked about, you will need to log. You need to keep track of. And you'll need to chase after QSL cards. It's okay if you want to do things on paper first, but eventually you're going to find that your database is going to get so big that you're not going to be able to keep track of where you're at. Any of the computer loggers will do most of this. I personally use Logic 9. It's one that you have to pay for. It's not free, but I've been using Logic for many years, and it works well for me, so I'll change at this point for it. But you will chase after QSL cards and try to pick them up. But logging is going to be the key piece. You're going to have to log all of your contacts for it. And not only that, that when you start DXing and start chasing stuff around the world, you're going to occasionally get these little letters in the mail with a card and it says, please confirm this contact. Send me your card. And you're going to need to look in your log to find out whether or not you actually made that contact. Because you're not going to remember after 10,000 contacts. You're not. Okay. You'll notice some of the procedural things that went across there. Most of the time you're going to hear 599 contacts. All of you know what these numbers mean, I assume? Yes? No? No? 599 is as ancient as radio is. It's a RST system. It's readability, strength, and tone that's related to. And so the numbers, the first number is a 0 through 5, which is your readability for it. So you could hear someone and be able to hear everything that they're saying and still have a low signal strength. That's not a big deal. So you're going to rate that as to your subjective factor. That's something that you realize that, oh, if I can hear every word that he's saying, it's obviously a 5. 5 being the best, 0 being I cannot understand a word you're saying. The next one is your strength. It has become known as S units. Most of the time people look at the little S meter on their rig and say, oh, that's about an S9, so that's a 5 and a 9, it means I can hear him. But it could also be a 5 and a 1. I've given lots of contact reports that are 5 and 1, or 5 and 0. That'll happen to you on 10 meters all the time. 10 meters is quiet enough that you'll have a signal that's come wafting in there, and you'll see nothing on the S meter. It'll be flat 0 for it. But you'll hear him just fine. 5 and 0. The last number is more related to, very rarely we hear anybody say anything less than 9. In the early days of voice communications, when rectifier systems and filtering systems were not nearly as good, you would get a tone that was associated with the transmitted signal. You still hear it occasionally, especially from some of the Soviet bloc countries like Kazakhstan and some of those places where their rigs are probably built minimum amount of components, and you hear an AC tone on it. And so you may rate that one less than a 9 in those particular instances. Most of the time on phones, you're not going to hear any kind of other than 5.9, although you'll hear people say 5.99, because most of the time it's always good, and you're not going to see anything less than that for it. QSB, when you hear someone say you got QSB on your signal, it means it's fading. You'll hear those signals. Where do Q signals come from? Anybody know? they come from CW, how old are they? They predate radio. They were developed on the land telegraphers in the 1800s. That's where all those Q signals come from. The 73 that we use and stuff like that, all of that comes from the land telegrapher.
Came from the publishing industry.
Say that again?
73 and 33, some of those came from the publishing.
Yes, that's true. 88, you know, so forth. QRM, you'll hear that a lot too. All right, getting QRM from an adjacent signal. QRM is static.
QRM, my wife.
Do yourself a favor and don't tell anybody that they're full quieting on the HF bands. You'll get labeled as a lid.
Tell them what a lid is.
A lid, that dates back to Maxim's day. It represents a inexperienced or uneducated operator. Don't be afraid of being called a lid though, because everybody has to start someplace. Has to start someplace. You're going to make mistakes. I remember on the Desecheo de-expedition, that's a little island down in the Caribbean. It's an easy shot for us to contact. But the pileups were immense because it was in the top 5 of the most wanted DXCC in the world for everybody that wanted it. The pileups were immense. I got a call. I was trying to work this station on 40 meters CW. I got a call from Kurt, K7CU, called me on the phone. He goes, Mark, you're on the wrong frequency. I wasn't operating split. I was calling on his frequency. There were lots of people that were cussing, you know, all this stuff like that. It was me. You're going to make mistakes. You're going to make mistakes. Don't worry about it. Just say, okay, learn from it and go on from there. So don't worry about it. Don't get offended or anything like that. Just do it. So